Hello, this video is on lesson 5-2 and we're talking about function composition. Learning targets. Write functions that describe the relationship between two quantities and to explore the composition of two functions through a real-world scenario. So we start on page 79. Let's go ahead and get started. Now, here's the key thing about this lesson. Write functions that describe the relationship between two quantities. What do we mean? What do we mean by two quantities? Well, say if you have money to buy a snack. So you want to buy snacks. How many snacks can you buy? Snacks. Well, we don't know. That's a quantity. We don't know how many snacks we can buy. How much money do we have to buy snacks? Well, that's another quantity. And so how do you figure out how much money you can use to buy how many snacks you have? Well, that is a real-world scenario. And we're going to use functions to describe the relationship between these two quantities. And those functions will help us explore compositions. Okay, so let's take a look at the text. Recall that Jim has a lawn service called the Greens Grass Guaranteed. On every mowing job, Jim charges a fixed $30 fee to cover equipment and travel expenses plus a $20 per hour labor charge. Number 1. On a recent mowing job, Jim worked for 6 hours. What was the total charge for this job? Okay, so what I did here is I asked you, my students, to become the detective. What important clues do we have in question number 1 and the paragraph on top in order to answer what was the total charge? So again, charge is a quantity. We don't know what charge is. See, charge stands for cost. That's a quantity. And it's going to be part of our function. And also, how do you determine the charge? Well, it depends on how many hours you work. So hours is another quantity. So what was the total charge here? Well, let's look at the information. We know that we worked for 6 hours, and there's a fixed $30 fee, which means you get charged once, and $20 per hour for a labor charge. There you go. Just put the information together. So we know that we want to find what the cost is, and we know how many hours we have. Since we're charged $20 an hour for 6 hours, we have to multiply them together. And since we have a fixed fee of $30, we just add those $30 at the end, and that, ladies and gentlemen, is going to give me my total charge. So 6 times 20, I believe that is 120 plus 30, so the total is going to be $150. There you go. We took the information. So you were the detective. You looked at the information, look for important clues, highlight those clues, put them together to form your equation and solve it to find your answer. Let's take a look at the next thing here. Number 2, if Jim works for T hours, okay, look at that. T stands for hours. So I'm being the detective here, highlighting that. That's an important clue right there. What will he charge for a mowing job? Take a look at that. It's asking for the charge. Write your answer as a cost function where C of T is Jim's charge for T hours of work. There you go. It gives you the notation for the function. C of T. C stands for, again, charge, and T stands for hours. So guess what? We basically take the information that we used to set up our first equation and just put it into the form of a function. Since our variable, my input, is hours, that's what my variable is. Whatever's inside the parentheses, that's what the variable is going to be in your function. So since I'm charging $20 per hour, it's going to be 20 times the number of hours. We don't know how many hours, that's actually the variable. So 20 times t, and then remember your fixed cost, which is $30. There you go. So t, whatever's in parentheses, is going to be your variable. That's your variable. And c, well, that's going to be your output. That's what you want in the end. Since in the whole question we're looking for the charge, that's what we want to get in the end. That is represented by the letter that is on the outside. Okay. Moving on to the next set of questions. If Jim takes 4 hours to mow 1 acre, okay, so we have some new information here. We have 4 hours and 1 acre, so these are connected together. It takes 4 hours to mow 1 acre. Jim prepares a cost estimate for each customer based on the size, number of acres of the property. The APCON company is one of Jim's customers. AppCon has 2 acres that need mowing. How many hours does that job take? So in the end, we want to find what hours are. So that's going to be my output, T. And how do we find the hours? Well, we find them by the number of acres. So as you can see, the number of acres is our independent variable, and the number of hours depends on the number of acres that we have. So we're actually skipping a step here. That's gonna help us set up the next equation, the equation for the next question. So if we have 2 acres and it takes 4 hours for each acre, well, we basically multiply 2 acres by 4 hours, and that's going to give us a total of 8 hours to find that will take to mow 2 acres. So 2 is the acres, 4 is the hours. Another customer has 8 acres of property. Write the equation of a function in terms of A for the number of hours. In terms of A for the number of hours T will take to mow the property. So again, hours is what we want to find in the end. It's going to be our output. That's why T is on the outside, output. In terms of A, well, that's another way of saying that A is going to be my input. And so take a look at what we did to find the number of hours to mow 2 acres. We take the number of acres, which in this case is going to be our variable. Again, whatever's inside the parentheses is going to be my variable. And we're just simply multiplying it by how long it takes to mow 1 acre, which is 4 hours. And so here's my function. Again, these are skills that you need to develop on your own in order to, going all the way to learning targets, write functions that describe the relationship between 2 quantities. So what quantities have we been working with so far? We've been working with hours, acres, and cost. So, okay, number 5. How much will Jim charge ApeCon to mow its property? Justify your answers. So we're trying to find the charge, which is equal to C. Okay. So remember the function for that included the charge. The function was C of t. So I have to use C of t, which is equal to 20t plus 30, I believe. Is that correct? Yes. And notice the input here is hours, and so AppCon, if you can remember, needed 2 acres to be mowed, and we found that it takes 8 hours to mow those 2 acres. And since we have 8 hours, 8 is going to be my input. So C of 8 is going to equal to 20 times 8 plus 30. And that's going to be 160 plus 30. And so since C is my output, which stands for cost, my total charge is going to be $190. Okay. So Jim is going to make a nice amount of money to mow 2 acres. I would gladly mow 2 acres and get $190. The functions in items 2 and 4 relate 3 quantities that vary based on the needs of Jim's customers. So quantities that vary, that's basically another way of saying variables. So we have 3 variables, and here they are. The sizes in acres, time in hours, and cost in dollars. So can you see that we had a 2-step process? First, we began with 2 acres. EPCON had 2 acres that we needed to mow. From those 2 acres, we found out it takes 8 hours to mow 2 acres, and from those 8 hours, we calculated the cost to be $190. So step 1 was to convert acres into hours, and then step 2 was to convert hours into cost. And so we had a total of 3 variables: acres, hours, and cost. Now we're going to explore the composition of 2 functions through a real-world scenario. What we did is we used the function what was it? T of A in order to go from 2 acres to 8 hours. And so T of A was 4A. And then to go from hours to cost, we used the function C of T, which was equal to 20T plus 30, to go from hours to cost. What we want to do is we want to form a composition of functions that goes straight from acres to cost. And that's the point of this lesson. Instead of going through 2 steps, is there one step that we can take to go straight from acres to cost and skip hours? There is, and so let's figure out how that works. Okay, so to begin this, there's also some important details we have to notice. Number 6, complete the table below by writing the rate of change with units and finding the slope of the graph of the function. Okay, so remember our function C of t was 20t plus 30, and t of a was 4a. The slopes are very easy to find. Rate of change, well, with units, that's going to be an important thing that you should always remember. 20 rate of change is basically another word for slope. So rate of change with units, 20 what? 20 blank for every blank. That's basically what it wants you to write. So if we go back to our word problem, notice our clue right here. $20 per hour. That is exactly the rate of change it's asking for. $20 for every hour. $20 per hour. That's it. So look at the text. What does the 4 represent? What are the units of the 4? 4 blank per blank. What is that? Okay. Complete the table below by naming the measurement units for the domain and range of each function. Okay. Remember how we took the function and t, we called it as the input, and c was the output. This is the final result that we want to get. Input was hours, represented by t, and output was dollars, represented by c. Another name for input, basically all the inputs represent the domain, and all the outputs that are possible represent the range. And so if we want to find the units for the domain and range, we basically have to just find out what does t represent and what does c represent. T represents basically the hours, and so right away we can find what the units are. They're hours. And c represents the cost in dollars, and so we have dollars. Same thing with t of a, where a is going to represent my domain and t is going to represent my range. So remember, whatever is inside the parentheses, your input is gonna, all your inputs put together represent your domain, and all your outputs put together represent your range. And just find out what does each variable represent. What are the units of each variable? So pause this video, determine what are the units. Okay, so a again represents acres. Acres, and then range represents time in hours. That's it. So this question is very important because it's very similar to a question on your embedded assessment. Calculate the cost to mow a lawn in a 2-step process. Complete the graphic organizer below by describing the input and output, including units for each part of the process. So again, this is, remember our 2-step process here. The first step was to convert acres into hours using the function t of a. And then the next step was to convert hours into cost using the function c of t. So this is actually what we have here, where this function is represented by t of a, and the next function is represented by c of t. Again, this is very simple. Your input is whatever's inside the parentheses. So you start with acres. And I hope I'm spelling that correct, to be acres, yeah. Our output was hours. Once we have hours, we use the function c of t as where hours are our input, and c is going to be our cost in dollars. So as you can see, this function, we plug in acres and we get dollars out. In the next function, we plug in hours and we get dollars out. Acres to hours, hours to dollars. And so t of a is represented by that function, and c of t is represented by that function. So let's read this. The graphic organizer shows an operation on two functions. called a composition. The function that results from using the output of the first function as the input for the second function is a composite function. In this context, the composite function is formed by a time to mo function and the cost for job function. Its domain is the input for the time function, and its range is the output from the cost function. Okay, let's see here. So now we arrived at the time to where we have to form the composite function. What is going to be my composite function that takes me from acres straight to dollars? Do you notice how we took acres, converted into hours, represented by this function, and notice that the output here is hours, so this function gives us hours. And once we have that answer, we basically plug it into my second function right inside, and we get our cost, our output in dollars. And so mathematically, how we represent this composite function is that since we took this function and we plugged it into the input of the second function, my composite function looks like this: C of T of A. So T of A is my input function, and C of T is my output function. That is my composite function. Okay. So remember that let's start with T of A. T of A is equal to 4A, and C of T is equal to 20t plus 30. And we have the composite function C of T of A. C of T of A. Again, since we have T of A inside the parentheses, this is my input function, and C of T is my output function. And so because T of A is in the parentheses, I'm going to take T of A, the expression for T of A, which is 4A, and I'm going to input it, plug it in to the variable of my output function. And so 20 is what I'm going to input for the variable t of my output function is the expression of my input function, which is 4a. And then I write the rest of my output function plus 30. And so this is what my composite function looks like. Here's the expression for it. Can you see how we input the expression of my input function, which is 4a, and we plugged it into the variable of my output function? So we can simplify this. 20 times 4a is going to be 80a plus 30. And so going all the way back, our one-step composition function is going to be using the function C of T of A, which is equal to 80a plus 30. That is the benefit of a composite function. So instead of having two steps using two functions, I just go from one step using a composite function. Now notice that In a composite function, we have the input function and we have the output function. But when we're talking about the input and output of the composite function, the input is the variable that we plug in. In other words, the domain, the input here is going to be acres, and the output of my composite function is going to be dollars. Notice that the outputs, which are both hours, are exactly, the output of my first function and the input of my second function are both hours. That is what is special about composite functions. The output of the first function should always equal the input of the second function. Since those are the same, the composite function skips the units inside in the middle, and we always start with acres as my input, or we start with acres as our input, and our output for the composite function is going to be dollars. And so what I like to say is we skipped the middleman. We went straight from acres to dollars, and we skipped hours. Okay. So remember when we answered question number 5, 5 required a two-step process where we changed 2 acres into hours. We got 8 hours, and from the 8 hours we determined the cost was $190. So what does C of T of 2 represent? Remember, in a composite function, your input is always all the way on the inside of the parentheses, and your output is going to be the variable on the outside. So what does the 2 represent? What is the variable of the 2, and what does C represent here? Okay, so number 11, write a sentence to explain what the expression C of T of 2 represents. Include appropriate units in your explanation. 12, why might Jim want a single function to determine the cost of a job when he knows the total number of acres? Well, this might explain it. Do you always want to go through 2 steps to determine the total cost, or do you just want to go through 1 step? Explain what the expression C of T of 50 represents. Include appropriate units in your explanation. So what does the 50 represent? By the way, when we solved this, that was basically number 5. We found that it equals $190. And so it equals 190. So this is going to be our output right here. Our input was 2. What does 2 represent? And what is our output is 190. What does that represent? So here is a similar setup. It's asking what does the 50 represent in this case? And then a very good question here, number 14. Explain what information the equation C of T of A is equal to 50 represent. So just take a look at number 11. What did 190 represent? And so what does the 50 represent here? Okay. And so that was basically it for lesson 5-2. And I had you work 15 to 24. Let me just make some quick notes. Again, you want to write a function, that between 2 quantities. Here our quantities are going to be dollars and hours. And again, units for the domain range. That's similar to what we did right here. where we found the units, and I told you how to find the units for the domain and range. What else? What is the slope of the function? Okay, that is similar to question number 6. Again, here we want to write another function, h of r, between two quantities. R stands for the number of rooms, h stands for the number of hours. And here is where you write your composite function to represent the cost of cleaning our rooms. And what is the value of C of h of 12 mean? So tell me what it means and also give me what is the answer. And this is important. Explain how a composition of functions forms a new function from the old original functions. So remember, here were my old original functions right here, and notice how I put them together to form a new composite function. Explain the process of how I did that. What else did I have? Okay, I think that's basically it. Thank you for watching.